Hello everyone, this is Shankar. In this video, I would like to discuss the solutions of control system questions given in recent ISRO 2023 exam. These questions are from electrical paper. Now let us go into the video. First question, consider the transfer function g of s is equal to 10 by s, the frequency at which the magnitude of g of s is equal to 0 dB in Bode plot is. Now from this question, of course this question is based on Bode plot, you need to find out what is the frequency where the magnitude of the given transfer function is 0 decibel. Therefore, what I can write down here, let us write g of j omega is equal to 10 divided by j omega. Now from this, if you take magnitude in decibel, take 20 log the right hand side, so you can write it as 20 log 10 minus 20 log omega. Now the requirement is, what is the frequency where this magnitude becomes 0 decibel. Therefore, when second term is equal to the first term, you can say simply the overall value can be 0. Therefore, this equation will be satisfied whenever omega is equal to 10 radian per second. Therefore, the correct answer could be 10 radian per second. Next, let us look into another question. The open loop transfer function of a unity gain negative feedback control system is given by g of s is equal to k divided by s plus 3 into s plus 7. What is the value of k for which the system damping ratio is 1.0? Therefore, what I can do here, unity negative feedback system, hence the closed loop transfer function, let me call it T of s, is equal to g of s divided by 1 plus g of s. Now by substituting this, k by s plus 3 into s plus 7 in the numerator, denominator 1 plus k by s plus 3 into s plus 7. Therefore, by simplifying this, we will get closed loop transfer function is equal to k divided by s square plus 10s plus 21 plus k. S plus 3 into s plus 7 in both numerator as well as denominator, it will get cancelled, and we will have this is the transfer function. Now, by comparing with the standard form of the second order transfer function, standard form is omega n square divided by s square plus 2 zeta omega n s plus omega n square. You can write omega n square is equal to 21 plus k. From this, omega n is equal to under root 21 plus k. Another comparison, 2 zeta omega n is equal to 10. Therefore, 2 into the required damping ratio is given 1.0, hence 1 into omega n is equal to 10. So, from this equation, what is omega n value? It should be 5 radian per second. From the previous calculation, by substituting omega n, that is root of 21 plus k is equal to 5. If you square it on both sides, we will get 21 plus k is equal to 25. Hence, k is equal to 25 minus 21. It will give you it will give you simply 4. So, for this question, the correct answer will be 4, k value of 4. Another question, an open loop transfer function of a unity feedback system is given by g of s is equal to 1 by s plus 2 whole square. The closed loop poles are, here also same procedure, closed loop transfer function can be written as g of s, which is given as 1 by s plus 2 whole square, divided by 1 plus g of s, 1 plus 1 by s plus 2 whole square. Therefore, this is equal to 1 divided by s square plus 4s plus 4 plus 1. Hence, it will give you 5. S square plus 4s plus 5. How can you rewrite the denominator? S square plus 2 into 1 into s. I can write, 2 into s. So, 2 into s plus 4 plus 1. 5 can be written as 4 plus 1. Therefore, 1 divided by s plus 2 whole square plus 1. Now, from this, if you simply look into pole 0 plot in the S plane, you can have the closed loop poles are located at minus 2 plus j1 minus 2 minus j1. Therefore, the closed loop poles will be located at minus 2 plus or minus j1. Hence, answer C is correct option. Now, let us look into fourth question. The transfer function C of s by R of s for the signal flow graph shown in the figure is, one graph is given and 4 options. We need to find out what is the correct answer from this one. Now, whenever any signal flow graph is given, the first step you have to identify forward paths. Forward paths. FWBD stands for forward. Now, first forward path M1 is equal to, now you can say directly 1 into G1 into C1. Therefore, I can simply write it is G1 and corresponding delta 1 minus, you need to take a loop which is not part of the first forward path. Therefore, that will be minus H1. Hence, what you can write? 1 minus of minus H1. This will give you 1 plus H1. Next, second forward path, that is simply 1 into G2 into 1. So, I can write here G2 and delta 2 will be 1 minus 0 because there is no path, there is no loop that is not part of the second forward path. Hence, you have to take delta 2 is equal to 1. Next one, you need to consider individual loops. You need to consider individual loops. L11 is equal to, first you have to take minus H1, order it is up to you. You need to identify individual loops, as many as possible. Second individual loop is G1 into, now this one, G1 into minus H2. So, G1 into minus H2. Hence, it will give you minus G1 into H2. Third individual loop. So, that is you can take G1 in G2 into minus H2. Therefore, G2 into minus H2. These are the three possible individual loops. Next one, you have to take two non-touching loops. Two non-touching loops. Let us use the notation L21. Here, minus H1 loop is not touching with minus G1 H2 loop. Therefore, you can write here minus H1 multiplied with minus G1 into H2. Therefore, G1 H1 into H2. Minus into minus becomes plus. Now, how to define delta? 1 minus L11 plus L12 plus L13 plus L21. Then you can say 1 minus, so minus H1. So I can say this will be plus H1, L12 minus G1 H2, hence it will be minus G1 H2. I hope L13 loop will be G2 into minus H2. Okay, G2 into minus H2. So this will be minus G2 H2. Now if you put here, it will be plus G2 H2 plus L21, that is G1 H1 H2. Now once you got all of these individual terms, now you can write down overall transfer function, that is C of S divided by R of S is equal to M1 delta 1 plus M2 delta 2 divided by delta. So, what is this value? M1 is G1 into delta 1 is 1 plus H1 plus M2 is G2, delta 2 is simply 1. Denominator 1 plus H1 plus G1 H2 plus G2 H2 plus G1 H1 H2. So, this is the transfer function. This is the required transfer function. So, G1 into 1 plus H1 plus G2, I think option C will match with the required answer. Next one, let us look into question number 5. This is another question from Bode plot. Transfer function of the Bode plot shown in the figure. Okay, now based on we have to find out the transfer function. Now, as the initial slope is minus 40 dB per decade, the given system will be type 2 system. Therefore, you can write down the transfer function as K by S square. Now, how to find out K value? Let us see that. Now, here M is equal to 20 log K minus 20 log omega square. Whenever omega value is equal to 0.1, what is given in the plot, the magnitude is given as 20 decibel. So, by equating this equation, what you will get? 20 log K minus 40 log 0.1 is equal to 20. Therefore, 20 log K is equal to 20 plus 40 log 0.1. Log 0.1 or log 1 by 10 is minus log 10, that is minus 40. Therefore, this value will be 20 minus 40 is equal to minus 20. So, what you have? 20 log k is equal to minus 20. Then k value is equal to 0.1. Therefore, the final value for the transfer function will be 0.1 divided by s square. Option B will be the correct answer. Next, question number 6. Here one state space model is given. By seeing the options, we need to find out whether the system is, given system is controllable and observable, right? So, first let us find out about controllability. To find controllability. So, what you have to do, you should define controllability matrix. Let me call it C suffix M. This is controllability matrix. Controllability matrix is defined as B, first column is B, second column is AB. So, this is where B, let me say this is matrix A, this is B and this is a C. So, first let us find out what is AB matrix. System matrix A is given as minus 3, 1, 0, minus 2 multiplied with B, 0 and minus 1. Then what you will get? Minus 3 into 0, 0 plus 1 into 1, it is 1. Next 0 in plus minus 2 into 1. So, that is 0 minus 2 will give you minus 2. Now, controllability matrix is equal to B matrix is 0, 1 and AB matrix is 1, minus 2. Now, what do you mean by that? Let us find out determinant first. So, this determinant is equal to 0 minus 1, this value is minus 1, that means it is not equal to 0. As determinant of this controllability matrix is non-zero, what you can say that the controllability matrix exists inverse. If any square matrix possesses inverse matrix, then we can say that rank of that matrix will be, that means rank of CM controllability matrix is 2 here because of 2 by 2 square matrix. Whenever that rank of controllability matrix is a full rank matrix, then the system will be controllable. This is the basic concept. The system will be controllable and this procedure is called Kalman's test. Now, similarly, let us find out observability. In order to find observability, first we should define observability matrix OM, that is first row is C, second row is C into A. So, first let us define the product of C into A matrices. C matrix is given as minus 1, 1, minus 1 and 1 and A matrix is minus 3, 1, 0, minus 2. Therefore, by multiplying this, what you will get? 3 plus 1, 3 plus 0, that will be 3. Next, minus 1, minus 2, that is minus 3, row matrix. Therefore, observability matrix is equal to C minus 1, 1 and CA 3 and minus 3. Then, if you find determinant, you will get 3 minus 3, that determinant will be 0. When determinant is 0, what do you mean by that? Observability matrix will not have inverse. In other words, OM is not full rank matrix. Full rank matrix. When it is not full rank matrix, the rank of OM matrix will be less than 2. Then we can say that the system is not observable. Then the system is not observable. Therefore, for this question, answer will be controllable and not observable. Let us go to next question. This is a theory question. It is a very straightforward question. In force current analogy, the flux of electrical system is analogous to displacement of the mechanical system. Okay, there is no need of any explanation. By just writing the basic equation, you will get this conclusion. Next, 8th question. The largest time constant of the characteristic equation. So, if you draw pole 0, there is no 0 here. If you draw simply pole locations from the given characteristic equation, you will find that one complex pole is located at -1 plus J1, another complex pole is located at -1 minus J1. Third pole is located at -3. So, the time constant is inversely proportional to real part of the pole. Time constant is proportional to real part of the pole. Therefore, for these two pole locations, you can have time constants 1 and 1/3 second. So, as the question is asking what is the largest time constant, you can select 1. Suppose if it is asking that what is the smallest time constant, that will be 1/3. Now, let us go to next question. The eigenvalues of matrix A. Matrix A is given. So, what do you mean by eigenvalues? Eigenvalues are roots of characteristic equation. Si minus A is equal to 0. Therefore, first let us find out Si minus A matrix. What is Si? S 0 0 0 S 0 0 0 S minus given system matrix 0 1 0 0 0 1 0 minus 2 and minus 3. Okay. Therefore, now matrix subtraction, S minus 0 will give you S, 0 minus 1 will give you minus 1, 0 minus 0 will give you 0. Next, 0, S minus 0, S, 0 minus 1, minus 1. Next, 0, 0 minus minus 2 plus 2, S minus minus 3, S plus 3. Now, if you find out determinant for Si minus A, what you will get? You will get S into S square plus 3S plus 2, okay, S into this one, S square plus 3S plus 2, right. Now, remaining two elements becomes 0, hence you can write it as a 0. Therefore, by simply factorizing, you will get S is equal to 0, minus 1, minus 2. So, 0, minus 1 and minus 2. So, these are the questions from ISRO 2023 electrical paper control systems. Okay. With this, we will conclude this video. Thank you for watching. I am a faculty at Home Institute, Hyderabad. We will offer the coaching for GATE and various PSU exams. If you are interested, you can call to the number given in the slide, or you can visit our website homeinstitute.com. Thank you for watching. If you not yet subscribed the channel, please subscribe. Thank you.